All right. So, what we're going to do in this section is we're going to look at another way to solve quadratic equations. And this is one of those other techniques I talked about in 7.3, which is called completing the square. So if you recall, in 7.3, what did we do? We took the square root of both sides of a quadratic equation. Well, we can only take the square root of both sides if we have what's called a perfect square trinomial, or in other words, a perfect square quadratic. So if you remember, I mentioned this in 7.3, but a perfect square quadratic is a quadratic whose binomial factors are the same. So I guess I can, I could replace trinomial here with, I could replace this with quadratic if I wanted to be more specific. But basically, by completing the square, we can make a quadratic into a perfect square quadratic. So for example, this right here, that's a quadratic. But it's also a perfect square quadratic because when you factor it, you get two identical binomial terms, x plus 3 and x plus 3, which you could write as x plus 3 quantity squared. The whole purpose of completing the square is to get a perfect square quadratic, because then you could write it this way. And if you write it this way, you could just proceed to take the square root of both sides to solve the equation for x. And that's what's so useful about completing the square, is it allows us to make a quadratic into a perfect square quadratic. And that's the important concept. And I highlight that right here. You can make any quadratic into a perfect square quadratic by what we call completing the square. So if I have a quadratic, which this is what it is, and this is just describing the process. The way you do completing the square is you look at the b coefficient, which is this value right here. You look at the value of b, you take half of it, and then you square it and add it to both sides of the equation. So I know this looks really technical right now, but I'll do it as I do some examples. But basically what you do is, to complete the square, you just take half of b, square it, and add it to both sides. So if I have an equation, a quadratic equation this way, I could just take half of b, square it. So here's the half of b, I add it to both sides and I square it, and I get this, which is more easily solvable than it would be if I couldn't complete the square. So with all that blabbering, we're actually going to, it's actually not too bad. It's pretty straightforward. It's just more busy work than difficult work, if that makes any sense. But the important thing to note is, by completing the square, you make a perfect square quadratic. That's the important thing to note. And when you complete the square, you could use that for any kind of quadratic. You could use that to solve any kind of quadratic equation. Completing the square works all the time. And it's best used when the quadratic cannot be factored. Because as you are already know, not every quadratic could be factored. We learned that when we did factoring. Not everything could be factored. But you still might want to solve a quadratic equation. So once I set this, equal to 0, now it's an equation, and we still want to solve it. You may not be able to factor it, but you could always do completing the square. So, like I said, you could do completing the square to any quadratic, but the whole purpose of it is to get a perfect square quadratic so you could solve the equation by taking the square root of both sides. So what we're going to do in this little warm-up exercise is we're just going to make, we want to find the value of c here that makes us a perfect square trinomial. So, or, basically a perfect square quadratic. So the way we're going to do that is we're going to do completing the square. So here's my quadratic. So this is the process of completing the square. The idea here is to identify the value b, all right, just like I did up here. So the value b is 10. All right, you include the sign as well. So you take half of that. And what's 10 over 2? That's 5. And then you square it. So then you square it. What's 25 squared? Oh, well, I'm sorry, I misspoke. What's 5 squared? 25. So that is now the value of c. That's it. That's completing the square right there. I just did it. Take half of the b value and square it. And then you just add it to the quadratic. So what you get x squared plus 10x plus 25. This quadratic is now a perfect square quadratic, because if you factor this, how do you factor this? Use the AC method. So which factors of 25 give you 10? 5 and 5. So you get x plus 5 times x plus 5. And as you can see, they're both the same, which means this is a perfect square quadratic. This process works for any quadratic. And this could be written as x plus 5 quantity squared. And that's the key point here, is that by writing it this way, from here you can use the square root property to solve for x. Excuse me. Sorry about that. I had raspy throat. All right. So let's actually look at some examples. All right, so I have 4 examples here. 1, 2, 3, 4. So this is the process for completing the square. If I have a quadratic equation, I have a quadratic, it's set equal to 0. This is the step-by-step process. Now, I'm not going to, go through it verbatim. I'm actually just going to do it as I go through the process. But basically, it's really not that hard, and you get better at it by doing problems, actually, by doing practice. So the first thing you want to do is you want to bring the c term over to the right side. It's a good habit, because then what you're going to do is you're going to look at the leading coefficient a. If that is 1, then you're just going to go on to complete the square. If it's anything other than 1, then you're going to divide through the whole thing by that value to make it 1. And then once you do that, then you're going to complete the square and then take the square root of both sides and solve for x. Now, that's just a brief summary of this whole process, but I'm going to go through it step by step with these examples. All right, so if I look at the first one, so the first thing I want to do is I want to bring the c term over. So subtract 4. Now I'm doing completing the square, because if you try to factor this, and guess what? It's not going to work. What are the factors of 4 to give me 6? There aren't any. 1 times 4 doesn't give me 6, and 2 times 2 doesn't give me 6. So I can't factor this, but I'm going to have to use completing the square, which always works. So, all right. When you do that, you're going to get x squared plus 6x equals negative 4. Now that I have it in this form, I want to look at the leading coefficient. The leading coefficient here is 1. That's good. So since it's 1, I don't have to divide through anything. I don't have to divide through the equation by the leading coefficient because it's already 1. So if it's not equal to 1, you would divide through, and you'll see what I mean in future examples. But since the leading coefficient here is 1, now I could just go on to step 3. I could complete the square. All right, let's do that. So, what's the b coefficient? It's right here in front of the x. It's positive 6. What do I do with it? Divide it by 2. What's 6 over 2? 3. Then you square it. What's 3 squared? 9. That's it. That's how you complete the square. Now, what do I do with this value 9? So once you complete the square for the expression on the left side of the equation, now you're going to solve for x. All right, so what you're going to do is you're going to add this to both sides of the equation. So you're going to add it to this side and this side. What you're going to get is x squared plus 6x plus 9 equals negative 4 plus 9. The plus 9 came from this step right here. You just add it to both sides to this equation. Now remember, from the whenever you do completing the square, when you introduce this number, this value right here, which is the value c, what kind of quadratic are you going to get? You're going to get a perfect square quadratic, and that's what this is right here. So that means this is going to factor now. It didn't factor initially, but now by completing the square, now I can factor it. So when you factor this, you're going to get identical binomial terms. What are the factors of 9 that give me 6? That's pretty easy, 3 and 3. So you're going to get x plus 3 times x plus 3. And that's going to equal negative 4 plus 9, which is now 5. And now you could rewrite the left-hand side as x plus 3 quantity squared equals 5. Come up here. So now that I have this, now I could solve for x using the square root property, which means you just take the square root of both sides. And that's what I'm going to do here. So you're going to take the square root of x plus 3 quantity squared. When you take the square root, what do? You add a plus or minus out front of the square root of 5. The square root of the square cancel out, which is exactly what we needed. So now you have x plus 3 equals plus or minus the square root of 5. And now all you have to do, now technically this does break into 2 equations. You don't have to do this step. You could just subtract the 3 from right here, and you could do it that way, or you could write this as 2 separate equations, whatever you feel like doing. X plus 3 equals positive square root of 5, and x plus 3 equals negative square root of 5. And now you could just subtract 3 from both sides. So you're going to get x equals the square root of 5 minus 3, and x equals negative square root of 5 minus 3. So these right here are my solutions. Now again, you could check this in your calculator, so I'm just going to write the solution set. I already know that these are solutions because the domain and range of a quadratic is, well, it's going to be defined for all real numbers. The domain is all real numbers, so the range may not be all real numbers, but the domain is going to be all real numbers. So I know, since these are both real numbers, they're going to work. But, as a good habit, it's always good to check your solutions. But I'll just write out the solution set as square root of 5 minus 3, comma, negative square root of 5 minus 3. Or you could write that as plus or minus root 5 minus 3. Up to you. Just a refresher. How do you check this in your calculator? Store these values in for x. So let me do this one. So root 5, go outside the root, minus 3. Because that minus 3 is outside the root. It's not under it. Store. So remember, the store button's right above the on button. Into the variable button. X is right here, underneath mode. Hit enter. So x, so this value right here is approximately, what? Negative 0.764. And I'll approximate this in a minute. But now that I have this value stored in for x, type in the equation, the original equation. X squared plus 6x plus 4. 0! Look at that. So that works. And this value right here is, so don't forget, that's negative root 5 outside minus 3. So that value is approximately negative 5.24 if I round it to the hundredths place. If you use the approximate solution in your check, you're going to get a number close to 0 because it's going to be a rounding error, but it will be close enough that you have to say that it works. So that's why you should use the exact value. This is the exact value. This is the approximate value. So, yeah. Let's look at another one. Now, sometimes when you do these, you're going to get fractions. Nobody likes fractions, and there's a neat little trick you could do to get rid of the fraction part. So, okay, first thing you want to do, subtract the 1. Bring the c term over. X squared minus 5x equals, when you subtract 1, you're going to get negative 1. The leading coefficient is 1, so I don't have to divide through anything. So now to complete the square. What's my b value? It's negative 5. Remember, you include the sign out front. Negative 5 divided by 2. Oh no! Negative 5 divided by 2 is not, that doesn't divide. It does divide, but it doesn't divide completely. Right? You're going to get a fraction. That's 2.5. Or negative 2.5. So just leave it as a fraction. Now what you're going to do is you're going to square this as well. All right. So I don't have the benefit of getting a nice number when you divide this by 2. You're going to have a fraction. So when you square this, it's going to be, well, negative 5 squared is 25, and over 2 squared, which is 4. So this is the value that you're going to add to both sides of your equation. This one and that side. So you're going to get x squared minus 5x plus 25 over 4 equals negative 1 plus 25 over 4. Alright, so here's where you get that fraction in there. The right-hand side, so negative 1 plus 25 over 4, well, I could write this as negative 4 over 4, and if I do the math there, you're going to get 21 over 4. So now what you're going to do, this is what I have. All right, this is what I have. All right, so if I ignore the right side right now, that's the quadratic I have. Now, there's a fraction there. So factoring that, because I did completing the square, this is a perfect square quadratic. But because I have a fraction in here, it looks really ugly. It looks really ugly. So how am I going to deal with that? Well, what I could do is I could multiply throughout both sides of this equation by the denominator. So the denominator is 4 here, right? So what I could do is I could find the greatest common factor between these two numbers, and they turn out to be the same number. So that's good. So what I could do is I can multiply both sides by 4 to get rid of the fraction. And that'll make it, not have a fraction, which is nice. So if I multiply both sides by 4, this is what I get. So I distribute the 4, I'm going to get 4x squared minus 20x plus 25. Because when I multiply 4 times 25 over 4, the 4's cancel and you get 25. And 21 over 4 times 4, the 4's cancel, you get 21. Now, don't make the habit of don't subtract the 21 over here. You want to keep this over here because you want to realize this right here is a perfect quadratic, perfect square quadratic. I'm just writing perfect quadratic for short. And this factors to two identical binomials. So because you know that, factoring this is a little more efficient because what are the factors of 4? 1 and 4, 2 and 2. But I know which ones I need. I need the 2's, right? Because they have to be the same factors. What are the same factors of 25? 5 and 5. Beautiful. The middle term's negative. So that means the terms in both of them need to be negative as well. So when this factors, if you factor this the AC method and you do it that way, you'll get the same result. I'm just going through this a little more quickly because you should be a pro at that by now. When you factor this, you're going to get 2x, right? Because the 2's have to be identical and the 5's need to be identical. And now, because this one's negative, I need a negative and a negative, right? Because that's going to be negative 10x, which gives me negative 20x. This is positive. Negative times a negative is a positive. Those are the factors of this. And that equals 21. Okay. I could rewrite this as 2x minus 5 quantity squared equals 21. And now you could do the square root. We're going to get, so the square root of this is going to cancel each other out. You're going to get 2x minus 5 equals, what do you have to include here? Plus or minus square root of 21. All right. So now, well, the square root of 21 doesn't simplify because you can't factor a perfect square out of that. So we're going to leave this as is. Now, from here, you could break it up like this, like I did up here, or you could just subtract, you could just solve for x directly. I prefer doing it that way because it's more efficient. Subtract the 5 from both sides. So you're going to get plus or minus the square root of 21 minus 5. And then divide by 2. You're going to get x equals plus or minus the square root of 21 minus 5 all over 2. So you have two solutions here. Plus root 21 minus 5 over 2 and negative root 21 minus 5 over 2. But you could write them separately like I did here if you want to. There's the positive one. There's the negative one. And, if you want to approximate this in your calculator, you could certainly do that. Just be careful how you type it in. So because this is a fraction, I'll just use parentheses. So root 21 outside the root minus 5. Close that off. That's the numerator. Divide that by 2. So that's the approximation. Let me get out of the glare. That's the approximation of this value right here. You could round that to the thousands place, so negative 209. Store that in for x if you want it. So store x. Now just type in the original equation. You should get 0 when you hit enter. So x squared minus 5x plus 1. Well, that's weird. Did I make a mistake? What did I do? That shouldn't have happened. Oh, wait a minute. I see what I did. I made a mistake. Yeah, I see what I did. I made a boo-boo. I'm supposed to add 5 here. That should be plus 5. My mistake. Sorry, guys. So that should be plus 5. Yeah, because when you're adding 5 to both sides here. So then you're going to have plus 5, not negative 5. Simple mistake. So let me redo that. So let's rewrite that. So parentheses root 21 outside root plus 5. That divided by 2. So this value is roughly 4.79. Now let's store that in x. Now let's type that in the equation. So x squared minus 5x plus 1. That's better. Yeah, you didn't get 0 here, but you know what this is? This is scientific notation. What this means is, if I were to write that, that's calculator language for negative 1 times 10 to the negative 12th power. That means this is, that means this decimal point is moved to the left 12 times. So you have a negative 0.000000 blah 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 1, which is very, very close to the actual number 0. So even though you didn't get 0 here, it's close enough to say that it works. And you could check this solution and it should work as well. All right, next page. 2 more examples here. So again, what you want to do is you want to bring the c term to the right. So I'm subtracting 45, so I'm going to get negative 45. All right. Now what do I have to do? Well, what's the leading coefficient? It's 5. So since this is 5, what I should do is I should divide both sides by 5. Since I did that, I could simplify each term. So 5x squared over 5 is now x squared, which is what I wanted. Negative 10x over 5 is negative 2x. And that equals negative 45 over 5 is negative 9. So now that's much better, because I want to make my leading coefficient 1. To do that, divide through by the leading coefficient if it's not 1. So now I can complete the square. I'm going to switch to blue. So when you complete the square, identify the b coefficient. So that's what? That's negative 2. You're going to do what? You're going to divide that by 2. What's negative 2 over 2? Negative 1. Oh, that's nice. It's a nice number. Square that. What's negative 1 squared? 1. Add that to both sides. So add 1. I don't know why my calculator is being weird, or my camera is being weird, but it is. Add 1 to this side. equals -9. Add 1 to that side. That just comes from this step right here. Alright, so remember, when you do completing the square, you get a perfect square quadratic here. This is now going to factor to two identical binomials. The right side simplifies to -9 plus 1 is -8. So what are the factors? Well, what are the factors of 1 that are giving me 2? Well, that's easy. 1 and 1. X, 1, 1. And the signs are going to be, this is negative and this is positive, so they both have to be negative. So now you have x plus, I wrote x plus 1. I don't know why. So I have x minus 1 quantity squared equals -8. And now from here, it's the same process. So from here, you're going to take the square root of both sides. Now, when I took the square root of -8, what do I have to include? A plus or minus out front. All right. So the square root of this squared, they cancel out, and you get x minus 1 equals plus or minus the square root of -8. Hold on to your horses. Don't add 1 yet. What do I have to do? Simplify this. Hey, guess what? There's a negative number under this root. So what do we have to do? We have to factor out a, does anyone remember? Yes, it's I. This is an imaginary number. Hey. So when I simplify this, when I simplify that, let me do that over here. So negative, or root -8, if I pop an I out of there, that's going to be I root 8, right? Now the square root of 8, what does that simplify to? Well, I could factor out the square root of 4 and the square root of 2, because 4 is a perfect square, which is 2. And that's root 2. So 8, or the square root of 8 becomes 2 root 2. So if I bring that up here all together, 2I root 2. So this becomes 2I root 2. Plus or minus 2I root 2. And now the last thing I gotta do is just add 1. So x equals plus or minus 2I root 2 plus 1. Ta-da! So my solution set is positive 2I root 2 plus 1, comma, negative 2I root 2 plus 1. So, yeah, if you want to inject that, what's the first thing you should do in your calculator? You should put it in imaginary or complex number mode. How do you do that again? Go to mode. Hey, look at that. It's already, if you go down here, see how it's real, ABI, A plus BI, that's complex number mode. It was already in that, so I'm good. So if you just type in these numbers, 2, remember the imaginary number is on the decimal button. It's right here, it's I. So second, that gives me I root 2. So second, that, 2, outside, plus 1. Let me store that into x, hit enter. That's the approximation of that complex number. Now if I type in the original equation, I should get 0. So 5x squared minus 10x plus 45. And I do. And if you check this one, you'll get that as well. Just replace the leading term with a negative, and you'll get the same. So just put a negative in of this, and you'll store that in x and blah blah blah. All right, last one. So, you know, before I go to the last one, I just want you to realize that, you know, when you're completing the square, you know, you could get fractions showing up like we did in the previous example, right? Here you get fractions showing up, so you can multiply throughout the 4 to get rid of the fraction. Sometimes you'll get imaginary solutions. You know, you may not get real number solutions, you might get complex numbered solutions. That happens. All right. Now in this one, the C term was already brought over, so a little work was done for me already. So I could just go on to the next step. I could just look at the leading coefficient. It's 2. So I could divide through by 2. What you get is x squared minus 8x equals negative 7 halves. Complete the square. Negative 8. Divide it by 2. You get negative 4. Square that. You get 16. Tack it on the left, tack it on the right. You get x squared minus 8x plus 16 equals negative 7 halves plus 16. This is going to factor to 2 nice binomials, which are going to be what? They should be the same, right? Because whenever you do completing the square, I know I sound like a broken record, but when you do completing the square, the quadratic you get after you do this is going to be a perfect square quadratic. The binomials will be the same. 16, the binomials, the factors of 16 that are the same are 4 and 4, so obviously they're going to go in. Now I just got to figure out the signs. This is negative, this is positive, so they both have to be negative. And that equals, so now you want to simplify this. Keep it as a fraction, don't make it as a decimal. Let's use our calculator. So negative 7 halves. Actually, let me go back into real number mode so it doesn't look weird. I suggest you do the same. So negative 7 over 2 plus 16. 12.5, but as a fraction, math fraction, it is 25 halves. Alright, so now I can write the left-hand side as x minus 4 quantity squared equals 25 over 2. And now from here, it's the same process. Take the square root of both sides. So if I take the square root, what do I have to put out front? Plus or minus. Get my arrow. What happens here? Root and the square cancel out. That equals plus or minus root 25 over 2. Now, I'm almost done, but again, what do I have to do here now? I have to simplify this number. I have to simplify that. Let me do that over here before we solve for x. So how do I simplify that? Well, I could break this up, right? Let me get rid of the number 3. I could break this up, right, using the square root property. So I could write this as root 25 over root 2. Well, what is the square root of 25? 5. And then I have root 2. Oh, but wait a second. I can't have square roots in the denominator. So what do I have to do? I have to rationalize the denominator. How do I do that? You multiply the top and bottom of the fraction by the square by itself. We did that in the first section in chapter 7. Multiply across. So you get 5 root 2 all over. Square root of 2 times the square root of 2 is the square root of 4, which is 2. So I have 5 root 2 all over 2. So yeah, that seemed like a lot, but it really isn't. This number simplifies to be this number. So when I come back up here, I'm going to have x minus 4 equals plus or minus 5 root 2 all over 2. And now, from here, I could solve for x by adding 4 to both sides. And there she is. So my solution set are the solutions. 5 root 2 over 2 plus 4, comma, negative 5 root 2 all over 2 plus 4. Let's check it. I'll just check one of them. But so when I do this, so let me use a fraction here. So fraction 5 root 2 divided by 2, right? Plus 4. Store that into x. Let's type in the original equation. So you can type this into the left side and you'll get negative 7. So 2x squared minus 16x, and you get negative 7. Voila! So that means this one works, and you can also do that one as well. So yeah, that is completing the square. You know, when you go through these things, the whole process itself isn't hard. It's just you see the steps when you practice it, and it starts to make sense that way. But yeah, it's really not that bad, in my opinion. A lot of students tend to get really frustrated with it, especially when fractions show up, because fractions are icky and no one likes them. Well, there are tricks you can pull out of your sleeve to get rid of them, but it works. Completing the square, it's a very useful technique. You're going to see it a lot, I promise. Alright, that's the end of the video.